I want to compute the domain of this function, f of x equals 1 over the square root of x minus 4. And I do mean natural domain in this case. I'm going to find every single x which it's possible to plug in. Now we haven't done any trig or logs or anything fancy yet, and so there's only two things that can go wrong with this function. We might divide by 0 and I see a fraction, so that's a problem. We also don't want to take the square root of any negative numbers. And so both of those problems are going to come up here. So we actually have two different requirements. We always want to phrase this in terms of what we require. And we require that the stuff inside the square root symbol, which is just the letter x, we require that that stuff be greater than or equal to 0. And we require that the denominator not be 0. So I have two different conditions in order for f to be defined. Now this first inequality is already solved, x greater than or equal to 0, so we don't have to mess with it. The second one, though, I can solve in 2 steps, adding 4 to both sides and squaring both sides. I get x not equal to 16. Definitely we do not want to count negative 16 here because you can't take the square root of negative 16. So I have these two conditions. And what I want to do is combine these. And it's the word and, so it's an intersection. I need the x's that satisfy both. So x is going to be greater than or equal to 0, but also x is not allowed to be 16. I'm going to write that in interval notation, and so it's 0 to infinity with a square bracket on the 0, and we're just going to cut 16 out of it. So I need to write the union of two intervals, and this example is finished. I'm going to level up a bit. I'm going to compute the domain of this function. So the denominator is familiar, but now I've added a fancy numerator, making this problem way harder. So I've got 3 problems now. The stuff under the top radical can't be negative, the stuff under the bottom radical can't be negative, and the denominator still can't be 0. That's 3 problems, 3 requirements. X needs to be greater than or equal to 0. Square root of x minus 4 not 0, and 20 minus x greater than or equal to 0. Did you notice how there's no radical here or here? I don't need to write those radicals when I'm writing my requirements, just the stuff inside of them. Now the first one's already solved, the second one we did before in the previous example, and the third inequality is pretty easy to solve too. You get 20 greater than or equal to x, or x less than or equal to 20. So I have 3 different requirements here. So I'm going to visualize this set. I have a number line here with 0, 16, and 20 marked. A good solution has to be to the right of 0 and to the left of 20 at the same time, which is kind of like saying you're in between 0 and 20. So it's all the numbers in between 0 and 20, but you can't count 16. So here's how I'm going to draw that. 2 solid dots at the end, squiggly, squiggly, squiggly all in between, and a bubble at the number 16. So written in interval notation, I have 0 to 16, 16 to 20, square brackets on the 0 and the 20, and a union symbol saying both of these intervals are good solution intervals. So this problem is finished. I just want to mention before I go that all 3 requirements can be written in interval notation. X greater than or equal to 0 can be written in this way, 0 to infinity. X not equal to 16 is this pair of intervals, negative infinity to 16, 16 to infinity. X less than or equal to 20 can be written this way. And that word and means intersection. So technically, I can write these 3 intervals, write intersection symbols in between, and then be done with this problem. I think it kind of looks like a mess. I think it's kind of the hard way of doing things. If you wanted to simplify this, I recommend doing some kind of basic visualization approach instead. But this is logically appropriate. So I just wanted to point out this is an intersection of 3 separate sets.